Question 7 is usually the one that disturbs students. It is always challenging a little bit, but not all that hard. The diagram shows two particles P and Q which lie on a line of greatest slope of a plane ABC. Particles P and Q are each of mass m kilograms. The plane is inclined at an angle of theta to the horizontal, where sine theta is equal to 0.6. The length of AB is 0.75 and the length of BC is 3.25 meters. The section AB of the plane is smooth. That means there is no frictional force. And the section BC is rough, so there is frictional force. Okay. The coefficient of friction between each particle and the section BC is 0.25. Particle P is released from rest at A. At the same instant, particle Q is released from rest at B. Part A, verify that particle P reaches B 0.5 seconds after it is released with the speed of 3 meters per second. Now, the first thing to do is to indicate the forces that are acting on these particles here. Okay, so I'm going to put here mg cos theta, okay, because of this inclination here, the weight here also tilted the same angle. So we must have mg cos theta here. And particle Q, do we know its mass? Particle Q, they are all of the same mass, which is m. So we shall have mg, then cos theta. Okay, so here there will also be R, the normal reaction. Then this P here, as it is coming down, it must have, there is mg sine theta on it, mg sine theta. And also here, we shall have mg, let me just put it on this plane here. It is mg sine theta is also there for Q. Okay, then after that, what else do we need? Let me also do something here. Since we are having cosine of theta, we shall need it. There is also actually mu r. This is mu r because it is this one is a rough plane. And there is a BC, and the coefficient of friction in there was given. You see that BC is rough, so there has to be frictional force that acts in the opposite direction to motion. Okay, now here we are going to have the theta is here. If sine of theta is equal to, because it was given here, sine of theta is equal to 0.6. 0.6 is the same as 3 over 5. So, and sine theta is opposite out of hypotenuse. That means what is here can be the square root of 5 squared, which is 25, minus 3 squared, which is 9. So 25 minus 9, that is 16. So 16, the square root, that will give us a 4. So meaning cosine of theta is going to be the adjacent, which is 4 out of the hypotenuse, which is 5. Or you can use 0.8. Okay, now we can start. Of course, since there is no vertical motion, this simply implies that the R here, the normal reaction, is going to be equal to mg cosine of theta. Now, we are supposed to verify that P reaches B 0.5 seconds after it is released. So first of all, F is equal to ma. We need to find the acceleration of particle P. So when it is going this way, in fact, let me put on, it is accelerating this side. So we have this force here. There is nothing that is resisting the motion because this one here is a smooth plane. So we shall have our force is mg, then sine theta, which is equivalent to ma. So m will disappear. This is 10 times 0.6, because that is the sine theta. That will be the A. So meaning acceleration here is going to be 6 meters per second squared. You see that? Then after this one here, we can also see that if we have gotten the acceleration, then we can know the speed with which it reaches what? With which it reaches Q here, or at point B. It is released from rest, so meaning the initial is 0, the initial speed. So using V squared, which is equal to U squared plus 2AS, then the final, or the speed with which it will reach B, is going to be 0 squared, then plus 2, acceleration, we have gotten it as 6, and then the distance, it is given here 0.75, so times 0.75. Okay, and what do we get here? This one here is 12 times, this is 12 times 0.75 is the same as 3 over 4. So this one will go here 3 times. So 3 times 3, that is a 9. Okay? So root of 9, that automatically gives us a 3. Right? So V here is equal to 3 meters per second. So this one, we have proved it. It reaches there at a speed of 3. Then the other one, we have to look for this time here. Okay, now I can use V is equal to U plus AT. The final speed, we have gotten it as 3, and then the initial is 0, acceleration, we got it as 6, then times the T, so meaning T will be equal to 3 over 6, which is actually 0.5. Very simple. That is that. Part B, find the time that it takes from the instant that the two particles are released until they collide. Now, when these two are released, remember they are released at the same instant, I think. They are saying at the same instant. They said that the coefficient of friction between the particle and it is that particle P is released at A. At the same instant, particle Q is released at B. So, what is going to happen is that this is what we are going to have here. P is released and then it moves. Then also Q is released and it moves. Probably these two, now they are going to meet somewhere here. So P must be moving with a far greater speed compared to that of Q. And remember, they are also even on this slanting one. So for P to meet this one here, it must be moving at a greater speed. Now, when they move in here, Q is going to travel this distance here, SQ. Then P is moving this distance here. So like that, P is going to move this distance here. Should I round there? Which is going to be SP. Okay? So it will move actually 0.75 plus some distance here, which will be the same distance Q has moved here. Do you get it? So that means the total distance traveled by P will be the one Q has traveled here plus the 0.75. Now, let's continue. Now, when P reaches Q here, okay, we need to know now the acceleration of P within here, okay, which will actually be the same as for Q because they have the same mass and the coefficient of friction between both of them is the same. So let's look at particle P at B, okay, or moving from B. So using F, which is equal to MA, we have now mg sine theta minus, there is now frictional force here opposing the motion, okay? So minus mu r, then this one is going to be equal to the MA. Remember r is here, mg cosine of theta. So we have m times this is 10, sine of theta is 0.6, then minus mu, r is mg cosine of theta, which cosine of theta, we got it up here as 4 over 5, which is the same as 0.8. Okay? And then is equal to MA. So M here will disappear everywhere. You see that? Then the coefficient of friction actually was given as 0.25. So if the coefficient of friction was given as 0.25, I can remove this one and just put the 0.25. Just like that. Then here we shall get a 6 minus, this will be 8 times a quarter. 8 times a quarter, what does it give us? That's a 2, which is equal to now the acceleration. So acceleration here is equal to 4 meters per second squared. This one here is the same for Q. Okay, same for Q. Remember, they have the same mass, the same acceleration due to gravity, the same friction, coefficient of friction here between them and the plane. So that is that. Now, what is the distance traveled by P? Okay, at B. Let me put it like that. Remember, we can use S is equal to UT, then plus a half AT squared. So we don't know the time taken. Okay, we don't know the time taken there. So let it be T. Now, the initial speed, by the time P reaches here at Q, then remember we have gotten the speed as 3 meters per second. Now, that becomes its initial speed for the movement within this region here. Okay? Now, we are going to have that U as a 3, then times T, then plus a half. Acceleration, we have seen it is 4. Okay, it is 4, then times T squared. So this one will actually be 3T plus 2T squared. Okay, then we can also go to SQ. We also use the same UT plus a half AT squared. Okay, but for Q, we are saying now from B, something. Q, remember the system was released from rest. Okay, so the initial speed for Q was 0, then plus a half. The acceleration is what? 4. So 4, then T squared. Okay, so the time they take in here, okay, the T, it's the same T there. Actually, for Q, it is not going to be like that. So if the T, the distance taken by, first wait, if for P, the time taken to move from B is T, okay, up to the point of collision, okay, then this Q here, the time it is going to take, it has been already in motion, okay? Q has been in motion by the time P reached here. Remember, they both were in motion. So this one was in motion as this one was also in motion. So by the time P reached here, it had moved, it had taken 0.5 seconds. So even Q had taken 0.5 seconds, maybe it was around here. Now, when P begins from here to, when it reaches B here, and then it moves this other side, so Q is also in motion. So the time the time P is taking from here up to here, we are now going to add it on the 0.5 for, that is the total time for Q that it has taken in motion. So it is like this. You are here and and another person is also here. You begin moving at the same time, okay? So you take 0.5 seconds to reach where this person was. Okay, so even this one has moved 0.5 seconds and is here. Now, by the time you reach here, now you take t, okay, you take t seconds to reach where this person is, and then you collide. Even this person is now taking t seconds. Okay, you have reached here, this person is here, then he's taking t seconds, you are also taking those t seconds. So that means this person here is taking a total time of 0.5 plus the t. Does it make sense? Now I will come back here and I say 0.5 plus that t. So t plus the 0.5 then squared. So this will be 2, then into, when we square this one, it will be t squared, then plus 2 times this times that. That one will give us a t. Then plus, when you square this one here, it will give us a quarter. And then when we open the brackets, it will be t squared, then plus 2t, then plus a half. That is the S of Q. Now, when P and Q, when P and Q collide, okay, they are the same distance from B. They are the same distance from point B. And I showed it here. They have collided here. So they are the same distance from B. So that is why when I was writing these expressions, I was putting on the B, okay? So we are having the one for P, we have SPB, then is equal to SQB, okay? So we have, for P, it is 3t plus 2t squared, then is equal to, for Q, it is 2t squared plus 2t, then plus a half, okay? Now we can see that 2t squared cancels with that. I can bring this one, this other side, it becomes a minus, then we shall have 3t minus 2t, that will be t, okay, which is equal to a half. So that means they collide also after 0.5 seconds. So t is equal to 0.5 seconds. Now the total time is going to be equal to, remember, P took 0.5 seconds, okay, to move from here to here. That is 0.5. Then it has also taken 0.5. So we add those two times and our answer will become a 1. So 0.5 plus 0.5, which is equal to 1 second. So that is that. And then lastly, the two particles coalesce. That means they stick together. They form one particle. When they collide, the coefficient of friction between the combined particle and the plane is still 0.25. Find the time it takes from the instant the two particles collide until the combined particle reaches C. Before collision, the velocity of P. What is the velocity of P? Because remember, when it reached point B here, when it reached here, it was moving with a speed of 3. By the time they collided here, because there is coefficient of friction here, and this one is also a slanting what? A plane. So the speed is changing. So we need to know the velocity of P before collision here, and also the velocity of Q before collision here. Okay, then those will be the initial velocities we are going to use when we are substituting into the principle of conservation of momentum. Momentum before collision is equal to momentum after collision. Then from there, we can find the velocity of this particle, the speed with which the coalesced particle now moves after collision. Okay, now let's go back here. Before collision, okay, before collision, what is the velocity of P? Velocity of P. We can use V is equal to U plus AT. So U at B, remember it was moving with a speed of 3. And then the acceleration, we found it as 4, okay? Then the time taken, we have seen it is a half. So 4 times a half, that is a 2 plus 3. This one will give us 5 meters per second. How about the velocity of Q before collision? So for Q, it was actually moving, it started from 0, released from rest, and then for it has taken a time of 0.5 plus 0.5. You remember the other T? You remember this one here? We have the T plus the 0.5. So the T, we have gotten it as 0.5, then plus the 0.5. You see that? So we shall have the 0.5 here plus the 0.5. Of course, that is 1. So meaning this one was moving at 4 meters per second. So using the principle of conservation of momentum, using the principle of conservation of momentum, we have momentum before collision is equal to momentum after collision. So we have MP, UP, then plus MQ, UQ, then is equal to, because this one is a coalesced particle, the masses add up. So MQ, then times V. So for P, we are going to have this one as a 5. So we have M, then times 5, plus for Q, it is also M, then times 4. Then here we shall have M, then plus M. Remember the M masses were M. So this one is 5 plus what? 4. That is 9M, which is equal to 2M, then V. Of course, M will disappear, and then V becomes 9 over 2, which is 4.5 meters per second. So this is the speed with which the combined particle moves, okay, after collision. You get it? Now, we need to know the distance that is left for this particle to move. What is this distance here left? So a half, remember the time taken here is a half. So if it is a half, then what do we get from here? I can substitute in any of these ones here. I can either substitute here or in the one of Q here, okay? So we can go back and we say that for T, which is equal to a half, then SP from B, this one is equal to, remember it is 2T squared, so it took a time of a half, and then plus 3T. This one here is 1 over 2, then plus 3 over 2. This is 4 over 2, which is a 2. That means these are 2 meters. So meaning that if this is 2 meters here, 2 meters, so the distance that is left here, this x is going to be 3.25 minus the 2. That is the distance this combined particle is going to move to C. Okay, so I will also write it here and say that therefore the combined particle travels 3.25 minus 2, which is actually 1.25 meters to reach C. Okay, now if S is equal to UT plus a half AT squared, our S is 1.25, which is equal to the initial speed. This is the one we have gotten. After they have collided, which speed does this combined particle move with? That is the 4.5. Okay, we don't know the time taken there. Then plus 1 over 2. Of course, the acceleration here is going to remain the 4. Okay, acceleration remains 4 because it is still on the same plane. Okay, because even if we say that, okay, it is one combined particle, it is going down, so there is mg sine theta, and then there is mu r. Okay, so we can have the combined mass is going to be 2m, right? 2m then times 10, then times sine of theta, was it 0.6? Yes, 0.6. Then minus mu is still 0.25. Then r is going to be mg cosine. So this is 2m because it is one combined particle. Then g, then the cosine was 0.8. Okay, and this one is equal to the combined mass is this, and then a. Of course, m, this 2m will go everywhere. So this one will give you a 6. Then here you will have 8 times that 0.25. It will give you a 2. Then it's equal to a. Do you see that the acceleration is 4? Okay, acceleration is still 4. So that is that. So I will just now put this one off because we didn't need it. But I was showing you that it is still what? 4. Then t squared. So this is a quadratic equation, which is 2t squared, then plus 9 over 2 of t, then minus 1.25, which is equal to 0. If I multiply everywhere by 2 to eliminate this one, I will have 4t squared plus 4t. 1.25 is the same as 5 over 4. So if I multiply by 2, it still remains that that is 2.5. 2.5, it still remains as a decimal. But then I can put this one in the calculator and I solve straight away. I'll go to equation, which is 5, then quadratic is 3, so put 4, then 9, then negative 2.5. So this one is a quarter, and then negative 5 over 2. So you skip space, a quarter, and then negative 5 over 2. You don't just write that, you need to show the examiner that you solved, okay? So cross multiply, give us a factor from which these roots are coming, okay? So that will be 4t. That will be 4t, then minus 1, okay? Because you bring the 1 back here. And then here, when you cross multiply, that will be 2t. Then bring the 5 here, it will add up. So we shall have 2t, then plus 5, which is equal to 0. Of course, time cannot be negative, so therefore our value here is going to be a quarter, or 0.25 seconds. So that is that. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.